Good afternoon, everyone. Welcome back to the tools track of the TestCon 2022 conference, where we are going to listen to Bas Dijkstra. Bas is an independent test automation consultant and training who, like me, is from the Netherlands. He sees much value in contract-based testing to reduce integration testing and end-to-end testing challenges, but he also noticed that consumer-based, contract-based testing is not so easy for teams and organizations to adopt. So he will explain why that is and how bidirectional contract-based testing will help us here. He will also give a live demo in his talk called Easier Adoption of Contract Testing with Bidirectional Contracts. As a little reminder, uh, the Publishers Pact and Manning will award nice ebooks for the most active participation. So write your questions in the chat, rate the talk at the end, and and perhaps receive one of those books. And with this, the stage is yours, Bas.
Thank you so much for that introduction, Martin. And also thank you for already confusing all of the all of the attendees. So we're going to see a live demo of consumer-driven contract testing with Pact, which sounds very similar to the book publisher Pact, but it's definitely not the same. As Martin said, my name is Bas Dijkstra. I'm an independent test automation trainer and consultant from the Netherlands, just like Martin. I've been in test automation for some 16 years now, and recently I've been quite active around contract testing. And in my talk today, I'm going to show you what contract testing is, how consumer-driven contract testing works, some of the challenges that you can encounter with the implementation of consumer-driven contract testing, and how bidirectional contract testing can help you address those challenges. Let me start by sharing my screen with all of you. There we go. So yeah, let's get started. Let's dive right in. As you probably know, as someone, you're probably testers, developers, managers, business analysts, scrum masters, POs, but you'll probably all have noticed that software systems are becoming more and more distributed. Where we used to have these monolithic applications where everything was in a single code base, and redeploying an application meant redeploying the entire application. Nowadays, software systems are becoming more and more distributed. So, built out of loosely coupled, independently deployed and running components that often communicate with one another through APIs. Distributed software development and distributed software systems have a number of advantages. Again, it's easier to deploy just a single component if it doesn't work, or if it needs an upgrade, or if it gets a new feature. You can do parallel development. You're not as tied to a single technology stack. So there's lots and lots and lots of advantages. But distributed software development also brings challenges, and those challenges are mainly around testing them. Because it becomes more, the more distributed your system is, the more difficult it gets to create a test environment, or spin up a test environment that has all these different components that together build your set. Together they shape they are your system. To bring all of these components into a test environment at the right time, in the right place, with the right state, with the right data, with the right configuration. Because you need that to do integration and end-to-end testing. Because just testing all of these individual components is not enough. You also need to address the question that you see on the screen right now. are all individual components and services able to communicate with one another? Traditionally, again, we did that, or we do that, and I see lots of teams and organizations still trying to do it that way, by doing large-scale integration and end-to-end testing, trying to make sure that all of these environments or all of these components are in the same environment with the right state, with the right data at a certain point in time, and that they all talk to one another so we can do our large scale integration and end-to-end testing. And so we try to do everything at once. And we try to test everything at once. And the more distributed your system becomes, the harder it is to get your environment in the right state to do that. I know organizations where it's the full-time role of a person and sometimes even a team just to make sure that there's test environments that are in the right state for other teams to do the integration and end-to-end testing that they need to do. So, and the more distributed your system becomes, the more difficult it is to get a representative test environment. And that's where contract testing comes in. So contract testing tries to address this challenge in two different ways, or in two ways, really. The first way in which contract testing tries to solve the puzzle of integration testing in distributed systems is by breaking down the puzzle into smaller pieces. So instead of focusing on the integration of everything at once, contract testing looks at individual integrations. So instead of asking, are components A, B, C, and D able to talk to one another, contract-based integration testing focuses on, is A able to talk to B? Is B able to talk to D? Is B able to talk to C? And so on. And the smaller the puzzle, the easier it probably is to solve. So that's one way in which contract testing tries to break down that puzzle, to make that puzzle a little bit easier to solve. The second fundamental difference between the traditional approach to integration and end-to-end testing and the contract-based approach is that, again, traditional integration and end-to-end testing is synchronous, which means that if we want to test the integration between A and B need to be in the same test environment at a given point in time, because they need to talk to one another. With contract-based testing, that challenge is made or that step is made asynchronous. That whole process is made asynchronous. We still verify whether consumer A is able to talk to provider B, but with contract testing, consumer A and provider B do not have to be in the same test environment at the same point at some point in time. Both play their role, both have their part, both have their responsibilities in that process. But it's asynchronous, meaning the tasks or the steps that consumer A needs to fulfill in contract testing is part of the build and release cycle of component A. And the same goes for provider B. The steps that they need to take in the contract testing flow, it can be done as part of their own build, and there's no time-based dependency. There's no time dependency because at no point in time do consumer A and provider B actually have to talk to one another, because what they expect from one another and the results, whether or not they can match those expectations, that's all being taken care of by contracts. And the most popular approach to contract testing these days is consumer-driven contract testing. So there are actually three different approaches, three different ways to do contract testing. That's consumer-driven, that's provider-driven, and that's bidirectional. And the most popular way to do this to do contract testing is consumer-driven contract testing, where a consumer starts by creating a contract, and in that contract contains expectations about the behavior of the provider. And the tools that support contract testing, Pact, Spring Cloud Contract, they formalize these expectations in contracts. Those contracts are then, they serve two purposes. That contract is then immediately input to generate a mock provider, which the consumer can then use to test its own implementation. But with the scope, within the scope of contract testing, the second role is even the second task, the second role for this contract is even more important. It's passed to the provider. From that contract on the provider side, a mock consumer is generated, which then invokes the actual provider, an actual running provider, to see if the provider, the current implementation of the provider, is able to meet the expectations written down by the consumer in the contract. And so how that typically works, especially with Pact, which is the tool that we're going to see in the live demo, is we have a consumer on one end, we have a provider on the other end, and we have a broker. A broker is a central repository which stores contracts as well as contract verification results. So both the consumer and the provider communicate with that Pact broker. And the Pact broker takes care of the administration of all the contracts, of the different versions of the contracts, of the contract verification results, and so on. So the first step in the consumer-driven contract testing flow is the consumer generating and publishing a contract. So that contract is published to the Pact broker as part of the build and deployment cycle of the consumer. The provider then downloads the contract and verifies whether its current implementation can meet all of the expectations for that contract. By the way, it's good to keep in mind that a contract is an agreement or a list of specifications between one consumer and one provider. Meaning that if a provider is consumed by 4 consumers and they all do consumer-driven contract testing, that provider needs to verify their implementation against expectations in 4 different contracts, which means there can be conflicts of interest, which we'll see in the demo. So the provider downloads the contract or the contracts and verifies its compliance, uploads, publishes the results, and those verification results can then be used both by the consumer as well as by the provider to determine whether or not it's safe to deploy into production. And within the Pact ecosystem, we do that using a tool called Can I Deploy, which queries the Pact broker for verification results and says, well, is it safe to deploy our latest release into production, or are there any known integration issues? So yeah, that's all well and good, but let's see how that works in practice with a little bit of a live demo. This project, this Java project, is a simulation of a web shop or a couple of components in a web shop. A web shop hopefully has customers. Customers place orders. Customers pay for these orders. Customers get shipped products. So we have a microservice called Customer Consumer that deals with all the data related to customers. There's another microservice, another in this case, it plays the role of a consumer as well. That takes care of all the data around orders. And both customers and orders use addresses. So a customer might have a billing address, and an order might have a shipping address. An order hopefully if it's a web shop, an order hopefully has a shipping address. Those addresses might be the same, but they might be different. In any case, there's plenty of complexity around that to decide. Well, we are going to separate everything around addresses in its own little microservice, and both the customer service and the order service depend, as consumers, depend on the implementation of that address provider service, which means that both the customer consumer and the order consumer have expectations about the way the address provider works. And with consumer-driven contract testing, they write down these expectations in contracts. Those contracts are then given to the provider, and the provider downloads the contracts, verifies its current implementation against the expectations in the contract, and publishes the verification results, which can then again be used to see if everything is okay. So this is just an example of what those expectations can look like. So I've got a couple of tests here that focus on HTTP GETs from the customer consumer to the address provider. So retrieving address data related to customers. And PACT, which is the tool that we're using for consumer-driven contract testing, allows us to specify these expectations into sort of kind of readable code. And so, for example, this PACT, which is a segment of a contract, or the expectations that a consumer has about the behavior of a provider in a given situation. So, for example, if I retrieve an existing address using an ID, I expect a response with a number of fields, and I've got some expectations around the shape of those fields, around the data types of those fields. So, for example, I expect an address type field to be present in the response, and that should be a string. I expect a number field to be present in the response, and that should be an integer. I expect an ID field to be present in the response, and that should be a UUID, meaning it should be a string, but not just any string. It should be a string that matches a specific regular expression. And so when I get an address, if for a specific state, so the consumer communicates to the provider, in this situation, in this state, I expect a response that looks like this. Oh, and the HTTP status code should be 200. And the customer might have similar expectations for different situations. So if the address ID does not exist, there's no expectations about the body. It's just the HTTP status code should be 404. And for an incorrectly formatted address ID, it should be a 400, a bad request. Those expectations are then input for the tests on the consumer side, which test the implementation of the customer consumer in this case itself, but they also write down the expectations to the contract. So if we run the tests for the customer consumer, two things will happen. So it tests the implementation of the customer consumer, but it also generates a contract that can be published to a pack broker, and then for the provider to download and to verify. So my tests pass on the customer consumer side, and let me quickly reload that from disk. There we go. It also generates a contract, which typically ends up in the packs folder, a contract between a customer consumer and an address provider containing all of the interactions, meaning all of the expectations that the customer consumer has about the behavior of the address provider. So the next step is to publish these contracts to a pack broker. And I'm using Pactflow here, which is a cloud-based pack broker. Currently, there are no integration. It's completely empty. So let's change that by publishing contract. There we go. And if we do a refresh, we'll see that we have a contract now between the customer consumer and the address provider associated with a specific consumer version. And right now it is not verified, which is not a surprise because it was published a few seconds ago. But we can look into detail about what are these specific interactions, what are the specific expectations for this consumer with regards to the behavior of the address provider. I'm quickly going to do the same thing for the order consumer because we have an order consumer as well. And this is probably a good moment to tell you a little bit about the difference in expectations that these customers have, because I've set up this code in a way that the customer consumer expects a successful delete to result in an HTTP status code 200, whereas the order consumer expects a different status code, an HTTP 204, which is a very typical HTTP status code in response to a successful delete. There we go. So we now have two different integrations, two different contracts, one for the order consumer against the address provider and one for the customer consumer. Now let's go over to the provider side. I need to quickly change this so that it actually uses the pack broker and not pull its contracts for some local packed folder. This is a test on the provider end, and the only purpose of this test is to pull the contracts from the pack broker, start an actual implementation or a running instance of this service, and for each of the states. So we need to list these explicitly. All of the different states, all of the different situations for which the consumers need to have some behavior verified. So we go to the address provider, and I'm going to pack.verifier. I'm going to live a little bit dangerously and say, well, immediately publish the results. So by default, it will pull the contracts from the broker, do the verification, but it will not publish the verification results yet. But I like to live a little bit dangerous. I want to immediately publish the verification results as well. There we go. That takes a couple of seconds. Luckily, not that many. But what the address provider again is doing right now is pulling the contracts from the broker, spinning up a local instance, and verifying that the current implementation matches all of the expectations from all of the different consumers. And all means 2 in this case. And if we now refresh it, and we can see that there's no issue between for the integration between the order consumer and the address provider, because now this contract has been verified, and it has been verified successfully. But for the customer consumer, the integration between the customer consumer and the address provider, there was a problem. And you can even see what the nature of the problem is, because the provider or the consumer expected a status code to 200 again for an HTTP delete, but the address provider actually returned a 204, which is what the order consumer expected, because it expected a 204 and it received a 204. So this is an example of the type of issue that contract testing is really good at finding. That's a mismatch in expectations for between different consumers about the behavior of a provider. So the customer consumer expects a 200 in case of a successful delete. The order consumer expects a 204, but the address provider can really only, or a version, a specific version of that address provider can really only do one. It can send a 200, or it can send a 204, but not both. And so this is an example of the types of defects that contract testing is really good at finding. So, by the way, all of the code that you see is available on GitHub for you to look at. I've also written a blog post series that goes into a little bit more detail about the code and about the situation, about contract testing, about the way contract testing works, about the way Pact works. So I happily invite you to give that a read as well. But let's talk a bit about implementation challenge. And now that we've seen how contract testing works and the problems it tries to address, the way consumer-driven contract testing or CDCT works, it has quite a few implementation challenges. It's a wonderful technique to break down the challenges of large-scale integration and end-to-end testing, but implementing it and doing it correctly and doing it right at scale comes with a number of implementation challenges. The first one is it requires teams to write tests. As you can see, you need to have tests in order to be able to do this. And that's not, and yeah, we should all say we are testers. We're here at a testing conference. Of course, you have tests, but still, for some teams, it's a lot of additional effort to do this, to write these tests. We've also seen that there's still some coupling between a consumer and a provider through these states and these different situations. And this coupling means that if you have a provider with lots and lots and lots of consumers, it doesn't really scale because each consumer will have their own states and the provider will have to take care of and manage all of these different states and all of the different setup for each of these states. And that doesn't really scale all that well. It's also quite difficult to get provider teams on board with consumer-driven contract testing because they typically say, well, I don't really care what these consumers want, or I don't want to go through we do our own testing. Why should we also do this and listen to all these consumers? So at just getting provider teams on board and say, well, yeah, and then all these different consumers are going to want all these different things from us. That's quite hard for that makes it difficult to get provider teams on board. And the final challenge is that getting testers on board with consumer-driven contract testing is also quite difficult. As you've seen, using Pact and using Pact in a fully consumer-driven contract testing fashion is a lot of code, is quite closely tied to the implementation of a service. It hooks into the code. You need to write unit tests. And traditionally, there's a lot of testers who struggle with that. And so getting testers on board to do this can also be quite difficult. Which is where bidirectional contract testing comes in. Immediate disclaimer. There's a couple of different flavors for packed brokers. Bidirectional contract testing is only supported by packed flow and not by the open source Docker-based packed broker that's also available. Bidirectional contract testing uses a different flow. So this is the traditional consumer-driven contract testing flow that we saw earlier. Bidirectional contract testing follows a different flow. It's no longer, so with consumer-driven contract testing, it's the consumer telling the provider how they expect the provider to behave. With provider-driven contract testing, it's the provider telling the consumer, this is how I behave. This is what I do. It's typically what public APIs do. With bidirectional contract testing, both the consumer and the provider give their own version of, well, this is what I expect and this is what I do. And they give that to an independent third party, in this case, the broker, or in right now, packed flow. And it's the responsibility of the broker to see if there are any integration issues. So there's no longer, it's no longer a matter of generating a contract on one end and giving that to the other. But now the consumer and the provider both give their own version of a contract to an independent third party who then compares these and checks for integration issues. So both the consumer and the provider generate their own contract. The packed broker checks for compatibility and for any integration issues. And as before, the consumer and the provider can then use the results to determine whether or not it's safe to deploy the latest version into production. So first of all, bidirectional contract testing simplifies the contract testing flow. It also puts consumer and provider on an equal plane, again, because it's no longer one party dictating the other what happens or what needs to happen. But probably one of the biggest selling points of bidirectional contract testing is that you no longer need packed, because you can still use packed for the consumer contract, but you can also derive contracts from existing technology and tests, meaning that a provider can simply use its open API specification, for example, as its contract. A consumer can use a contract generated from existing integration tests as a contract, which is what we'll see in the demo right now, because I also want to show you how bidirectional contract testing works. To do that, I quickly need to branch. There we go. Which adds another component, another service to our little microservices architecture here, which is a payment provider. There's an integration between the order consumer and the payment provider because an order needs to be paid for using a payment provider. A payment provider is typically a public API, so it doesn't care about what a consumer wants. Which makes it a horrible candidate for consumer-driven contract testing. But bidirectional contract testing works very well with these kinds of public APIs because the payment provider probably has a version of a form of a contract already in the form of its open API specification. I need to quickly fire a postman before I forget. And for the order consumer, it might already have some integration tests against the mocked version of that payment provider, and that mock already contains the the expectations that the order consumer has about the behavior of the payment service provider. Those are codified in the mocks. So how nice would it be if the implementation of that mock can be used as input for the contract, which is exactly what happens here. So this testing against the payment service client, it uses YAMOC. to simulate the behavior of the actual payment provider. And the people in the open source community, in the Pact open source community, have built a WireMock pact generator, which is a listener that can be added to WireMock. WireMock, by the way, is an HTTP API mocking library. This WireMock pact generator can be used as a listener, can be added as a listener to WireMock, and based on all the requests and responses that are received and sent during the execution of the integration tests, it can generate a contract from that, because that's the behavior that the consumer apparently expects of the payment provider. So if we run the tests again, this will now both run the traditional classic consumer-driven contract test to generate the expectations that the order consumer has for the address provider. But it will also run the integration tests against the mock version of the payment service provider and use that to... I see I've got 5 minutes left, by the way, so I'm right on time, no worries. This is quite a quick demo. So, but the nice thing is, for these tests, there's no use of Pact anywhere. It's existing tests that already use existing tools and infrastructure. It's just that on top of this existing infrastructure, existing test, we use a plugin or a listener in this case to generate a contract. So if we look at the generated contracts and quickly reload this from disk, we'll see that there's now also a contract between the order consumer and the payment provider. And these are generated from the existing WireMock tests in this case. So if we do another publish, this publishes the consumer contracts again, but it now publishes both, which means there's now also a contract, and as of yet unverified contract between the order consumer and the payment provider. So this is the consumer side of the bidirectional contract testing, and it no longer uses Pact. It just leverages existing technology. In this case, it's WireMock, but the support for different types of frameworks and tools to use to generate contracts from, and without having to go to the additional effort of using Pact and writing down all the expectations and the specifications. The support for different types of tools, so you can do that from Postman, using Cypress, Rest Assured, WireMock. There's all kinds of all different kinds, and the support keeps on growing. So bidirectional contract testing was introduced earlier this year, and the support for different tools and technologies, it keeps on growing. There we go. So this is the consume or the provider contract again. It is this, and please verify it if you don't believe me, but this is a base64 encoded version of the provider contract. And by sending that to the Pact broker, I can upload the providers. Again, bidirectional contract testing is both consumer and provider uploading their own version of a contract to the broker, which then does the comparison. So this API call that I'm going to make is going to upload the Open API specification, the provider side contract, by identifying, so, well, I am the payment provider, version 1, and this is my contract. I'm going to send that to the Pact broker, and now the Pact broker has done it has already done, by the time it's done refreshing, it already has done the verification. So because it says, well, success, because I've got a contract comparison. I've done the contract comparison. I've got a consumer contract. I've got a provider contract. I've compared them, and there are no integration issues. Meaning it's safe, at least for this specific integration, to deploy a new version either of the payment provider or of the order consumer. And again, the biggest benefits of using bidirectional contract testing is it's a level playing field again. So it's no longer either the consumer or the provider who's in charge, but both are equal. And perhaps the biggest benefit for teams who are trying to look and adopting contract testing is that there's a lot of support for existing tools and libraries and technologies, which makes adoption of contract testing a lot less effort than it would be with traditional consumer-driven contract testing. If you want to read more about bidirectional contracts, the people behind Pactflow have a lot of useful information. The blog post series that I've talked about earlier also have the sixth and final one in that blog post series is about bidirectional contracts. The code that you've just seen, that's just a different branch of the same repository. And that is exactly on time for the Q&A, I think. So I'd love to hear if there are any questions.
Indeed, Bas, you're nicely on time. And actually, quite a few questions were raised from your talk. For instance, Tomasz Kuretsky asks, what do you think about implementing contract testing for messaging? As an example, Kafka messages. It seems, he says, that a provider-driven contract testing is then a better approach, as the provider should decide what message is being sent and the consumer has to align to that. And do the tools like Pact or Pactflow then support it?
So Pactflow is just the broker. I know Pact support messaging-based APIs. So the examples that you've seen are REST. But Pact definitely supports messaging-based APIs. With Kafka, which I think is more of a publish subscribe kind of thing. I'm not too familiar with that and all. And so then indeed it seems like a provider-driven approach might be a better way to do it. And Pact is not a provider-driven contract testing tool. It's a consumer-driven contract testing tools. So again, to give a proper answer to this, I need to look a little bit deeper into how Kafka that. So I sort of kind of know what it is, but to give a proper answer, I'd have to look into that a little bit more deeply. I know for a fact because the client I'm currently working with, we're using Pact, and we're using that for messaging-based APIs as well, and not just for REST APIs.
So there are definitely possibilities there, and the details are, of course, in the documentation to be found. But already there's at least half an answer. Thank you, Bas.
Yep.
Gordana asked, when you generate contracts from consumer side, against which data on the provider side is asserted? If, for example, we have two microservices, each having their own databases, and consumer A is doing a request to get something from the other microservice, do we need to prepare that data on the provider side, which consumer A will request? Long question. I hope you.
No, absolutely, and that's a very, very, very good question, because it's a trick. It's a fine line between testing the integration between a consumer and a provider and testing the implementation of a provider. So you need to be careful when you say, well, what do we want to test? What do we want to verify? And because the more you rely on specific data being present both in the consumer and the provider, the more coupling you get, and the more brittle this kind of testing gets. So when you generate contracts, so that's why typically with consumer-driven contract testing, you assert on the shape of a response and not on the data that's in there. So because if you would want to assert on the data that's in there, that's what you're testing then is the implementation of the provider, and that's the responsibility of the provider development team. To test the integration, so is consumer A able to consume the responses being sent back by a provider, being returned by a provider, what you typically are most interested in is at what shape does that response have. So what are the fields in there? What are the data types of those fields? But the actual values should be of less importance, because if they are so important, then you're actually testing the implementation of the provider, which is a different kind of test. So that's a test, that's a functional or an acceptance or whatever you want to call it, test of the implementation of the provider. And contract testing doesn't replace that. Contract testing is something that you do next to that.
Clear. Contract testing is about the technical integration rather than the functional integration, mostly.
Exactly. Yeah, I like that distinction.
Yeah, system integration test is a term that people will be perhaps most familiar with. So that's what it could replace, or at least prepare for. Let's put it that way. That brings us to the end of the scheduled time. Thank you very much, Bas. Please, attendees, rate this session, and we'll hope to see you in a few minutes for the next session in the tools track.
Yeah, thank you, Martin, for hosting, and thank you to everybody who attended for taking the time out of your day. And I hope to see you again sometime soon. You can always find me, LinkedIn, email, website. So by all means, do stay in touch and have a great day. Cheers.
Bye-bye.